LEMA. LEMA is our licensing enforcement and monitoring application, which was and is a flagship project that we started in the EPA a couple of years ago. I meant to put a slide in here that I don't have, that was just to be a blank sheet, because that's what LEMA was when we started off. It was very much a blank sheet, a start from scratch, how are you going to do it thing. And that sometimes isn't a very easy thing. You think it's the wonderful thing to be given a blank sheet and carte blanche, but it's not that easy to start and pull things together. People ask us for the justification for LEMA. I just showed this slide, and it's a very small section of what I think a lot of people will be familiar with in a lot of offices. We manage different types of applications for licenses, and anybody who's familiar with a planning process, the process for a license application is very similar. So this is just a very small part, but standard applications run from, minimum about two lever arch folders of information to, for bigger sites, something like 13 to 14 lever arch folders of information, which includes lots of data, lots of maps, lots of process diagrams, and so on and so forth. Anybody will know that information in lever arch files is, other than when it's been looked at by an inspector, is practically useless. You can never go back and gain any information from that. And the process of actually managing and processing that application is quite laborious and manual. We had a great initiative, I don't know how many years ago, this may be 6 or 7 years ago, that we were put in a document management system, which we did, but effectively that's just an electronic version of lots of paper folders. It's okay for getting information out to the public, but it doesn't do anything for efficiency or for moving a process on internally. We kind of looked at what is it that we're doing in this licensing process, and we just drew out some arbitrary bubbles to say, well, it's roughly this and that and the other, and we do that in different offices. And these bubbles are mainly what the licensing people do, and the enforcement people do a lot of these bubbles, and we have our monitoring people who take samples who do some of this stuff. And in the good tradition of good organizations, we all do that completely independently of one another. And we'd like to have as much handover of things and formality between these boundaries as we can. The concept of LEMA was to say, well, look, this is all the one process. It's an end-to-end process, and we have to begin to look at it like that and deal with it like that. And I mean, I mentioned earlier challenging the business about what their business processes are, and a lot of LEMA has been very balchy with our business and telling them that really they didn't know what they're doing. Full stop. But we began to kind of get some sense out of it. The scope was to develop an end-to-end licensing, enforcement, monitoring, and reporting application, hence the name. It was to employ contemporary ICT and GIS technologies to enhance the work procedures of agency staff through the elimination of duplication, reduction of reliance on manual procedures, and promotion of strategic practices. We were very, I suppose because we had a strong hand in it, we were very upfront about writing in the importance of GIS into this whole LEMA process, because we were, I suppose we were convinced at that point, and it had to be proven, that GIS was going to deliver a lot of efficiency for the business. We knew that this was a big animal, and we decided it was going to be a phased approach, and we would start off with the area of urban wastewater licensing. The key benefits were that we were going to modernize our system and architecture, eliminate duplication of unnecessary manual processes. We were going to have a better handle on our financial management, reduce maintenance of the multiple IT systems that we already have, and upskill our IT staff, and effectively really get the business to move to more streamlined approaches to their work practices. Really the plan was to get all the incoming information as electronic data coming into the systems via web forms. We'd automatically then begin to be notified of site incidents from the licensees, and they would come directly into the enforcement inspector, and we would do things like automatically assess compliance of monitoring returns and so on and so forth. I mentioned, and I showed you very quickly, a demo of the automated risk determination DREAM, and this, we operate a system of risk-based inspection. So we try to assess which facilities do we license that pose the highest risk, and as we only have a limited amount of resources, we focus the majority of the resources on the higher risk sites. And effectively, we wanted to develop a greater understanding of the outcomes of what it is that we do. Like a lot of organizations, sometimes we begin to, let's say, monitor what we do and assess what we do based on very arbitrary things. For us, the number of inspections. Again, I use the term, well, so what? If you've done 1,000 inspections and it doesn't actually result in any environmental improvement, have you done anything at all? So we really wanted to begin to be able to focus in on more meaningful outcome indicators that show that what we were doing was making a difference. So LEMA, and it was a big undertaking and a big system, but it doesn't live alone, I'm afraid. GIS, we knew our systems were going to be a big part of LEMA. We were going to base a lot of the work on LEMA. We also had DREAM, which we built, this risk assessment methodology, which relies heavily on GIS and also will rely on the information that's in LEMA. Also, it links in with an Aquarius, a database we have for managing all our water data information, which in turn reports to the European system, WISE, and takes in data directly from the EPA's own laboratory information management systems. We have Eden, which is our portal where we interact with local authorities and we take data in from the local authorities, from their LIMS systems and also other reporting streams. Alder is a portal where we interact with industry, the other private sector, I suppose, of the stakeholders that we license. And we had this existing document management system that I mentioned. And then the host of other IT systems that people have internally. And LEMA had to interact with all of these. In the process, there are really kind of three main stakeholders. There's ourselves and our internal people, our inspectors and so on. There's the general public who have a role in the licensing and the enforcement part of all the facilities that we actually control, and the licensees themselves who make applications and who are then enforced by the EPA. We have this other little grey group called statutory consultees of other public organisations that we must consult, but they're mainly dealt with by and large very similar to the public. It means that we've kind of got three worlds in LEMA. We have our own internal world for EPA staff, which is mainly focused in CRM, CRM 2011, Microsoft CRM 2011, where we have all these various little business processes that we have now built in there. The licensees see their own version of LEMA through the Eden and Alder portals, and they see bits or subsets of that, of the business processes that are seen inside. And again, the public interact through our public website, epa.ie, and they get to undertake the relevant parts of their business through that forum. So, I mean, we have the system objectives effectively is that we have an application process. We will have the opportunity for public to submit their observations on the application. We wanted to kind of automate the GIS aspect of that application and bring that into the system. We have all of the records we get electronically to be managed. We set a goal of having an automated license generation facility, which I'll talk about a little bit later on. Once the license is generated, it has to go through an approval process. The license is issued, and then it's enforced by our enforcement team. And again, the goal there was to do as much of that enforcement as we possibly could electronically, and to remove that burden from the inspectors and to create that efficiency. We wanted to be able to do as much of our monitoring and our on-site auditing using mobile applications, and then really utilities to manage the overall workflow. This is just a quick snapshot of the public complaints facility. So they now go online to make their complaint about a facility, or they can make a submission on an application. The licensees have their own portal, as I mentioned, Eden and Alder, and they get a more detailed view of their applications, and they can look at various aspects and see where their license is in the system and so on. And the internal staff really utilize the CRM view, and you can see we have integrated GIS into the CRM for various functionalities, presenting the inspectors with the information they need here, I think, to look at an incident. Very quickly, I suppose what we have achieved and what we set out to achieve is an electronic interaction with our licensees. So in the case where there's an incident, the licensee logs into their Alder portal. They give us the details of the incident. It comes into our LEMA CRM and onto the inspector team who deal with it. The inspectors probably raise a compliance investigation and maybe issue some actions back to the licensee. That arrives in the Alder portal. The licensee looks at that. They're notified that they have something in there. They send a response with further information back to the inspector team, and they may again ask for further information. And in the good old public sector way we do things, this can go on ad infinitum for many iterations, and eventually this compliance investigation is closed. This is again just a view for the licensee for raising an incident. For example, they just get multiple forms that they work through, the type of classification of the incident and so on, and what corrective actions they've taken. There are a lot more forms in there. But I mean, the key there is that we now have, rather than hard copies and letters coming in and out, we have a fully electronic system that we are transacting with the licensees and with the complainants. And then, I suppose, once you get more and more electronic information and records into your system, you can begin to build up these profiles and pictures. And this is helping the OEE people to focus in on areas. What are the big problems that are arising in urban wastewater treatment plants? When we go out on inspections, what are the issues we need to focus in on that are going to drive compliance? Okay, to talk a bit about GIS in that context, and I won't stay too long on this, but we've progressed, I suppose, in terms of GIS in the EPA, starting off really in the late 90s with desktop GIS, moving to spatial data expansions, our first internal web GIS viewer, our external viewers, moving on to more smarter technologies, and now really looking at GIS as part of that overall systems development and in workflow. LEMA, this is a very simplified version of it, but when we were building it, and we were looking at, okay, well, there's these elements to it. We've got the corporate database, which is really, a CRM database, and we have our Aquarius monitoring database, as we said. And we've got the spatial databases, raster and vector information. And then in the middle, we've got these new kind of things which are coming into the frame, these analysis database. ACT is automated assimilative capacity model, which will, for an inspector, if they pick a point on a river, it'll tell them what the impact of the discharge load is going to be on that river. DREAM I mentioned, and proximity I'll talk about a little bit more. We began to develop other systems, one we called Environmental Information System, or we're christening it now, and lo and behold, do you know what, we're building on the same infrastructure again, and we're using more and more of the same services. And that's been the case as we're building more and more of our applications. Our bathing water system that we've rolled out is using the same web services and analysis services as LEMA, and so is the domestic wastewater treatment systems, as they're currently called. The name changes, or septic tanks to the layman. Again, we're using the same services that we were using in LEMA. So the message here is that really we're looking at GIS much more as a service than anything else. Proximity, one of those web services, just wanted to talk about a little bit. It really is the heart of these. It's a kind of a location-based service which relates all of the entities to one another. And the idea is, once we enter a point into the system, it'll tell us what's around it and what may be impacting on it. And really allows us to present the information to the inspector in a concise way. You know, if you have a discharge point, you've got monitoring stations, drinking water abstraction, special areas of conservation and hydrometric stations. The proximity database works out where all of those are and brings that information back to the inspector. I'll make the point, the proximity web service is not a spatial database web service. It's not in SDE, and it's actually in SQL Server. Again, we processed all the information in the GIS system and then put it into a SQL Server database because we found it was a quicker way of actually serving that information back to the users. So, I mean, if you were to look at our kind of information viewer, effectively we've built this into the information viewer as well. So it tells, if you pick a point, it tells you what's upstream, what's downstream, what the water quality is, underneath what the soil type is, all of that. It brings you back all of the information we have around that point in a kind of a concise way. Just to give another example of what it does is that in this licensing process, when you submit a license application to us, we have the discharge point location and we have this automated license generation. So what proximity does is it checks what's downstream of this discharge point. And if it sees that there's a shellfish area downstream, it tells the system there's a shellfish area downstream, and the system automatically puts in the conditions in the license that relate to the shellfish water. So effectively, we're automatically building the license based on what's in the area relevant to that discharge point. So the things we're looking at there that we have are transitional waters, coastal waters, groundwaters, lake waters, all of these. They're all in our proximity database, and we can kind of deliver this information back, not just as layers of information in a GIS viewer, but as in a kind of a processed answer to a question. And really, this is where we're trying to get to. We're trying to get to SIDS when we ask them what's going on here with this water quality, that we can know that the water quality is poor to an increase in phosphates, and by the way, there's a discharge from a non-compliant urban wastewater treatment plant upstream, and the main land use in the area is agriculture and so on. I mean, it's again about pushing this information back out to the users in a way that they can understand it, not as a complex series of maps and so on. So, we're saying that GIS is no longer just for standalone mapping. The focus is on integration into intelligent business process applications. Our proximity web service for us is a cornerstone. Dream is an example of how we're using it. But again, just to reiterate the point that Kuhn made earlier, a word of caution, it's more important than ever that the underlying data here is of a high quality. Because people act on the final result. They're not involved in this process of coming up with the final result anymore, and they don't spot the errors. So what we get, for example, in DREAM is that each facility gets a risk score. So your risk score is 500 or it's 400. And that's what we act on. We're not going back and asking about, okay, well, how far exactly was that away from this, or how far what it is. We're acting on the information that comes, and if the underlying GIS data sets are wrong, then the overall result that those people, or the information that they're acting on, is going to be wrong. So that's it. Thank you very much.